Hello and welcome to our Tech Tuesday webinar Simulation Models, the Turbo for Commissioning. My name is Tobias Wenneker and today we will be looking at how you can start up the COMBIVERT F6 drive controller and S6 servo drives in the shortest possible time with the help of simulation models. This saves you time and of course costs, benefits and faults such as programming errors in the control code can be detected and eliminated in the advance of the real commissioning. More on this in a moment, but let's start with a brief look at the devices we are talking about today. The drive controller COMBIVERT F6 and the servo drives COMBIVERT S6 are two of our drive series drive controllers. The frequency inverter COMBIVERT F6 has got a power range from 2.2 kilowatts up to 450 kilowatts. The COMBIVERT S6 servo drive has got a high overload in the current range from 2.6 amps to 6.5 amps. The functional consistency across the entire power range is one of the benefits. The high scalability and the different installation and cooling types as well, like liquid cooling or air-cooled. Wide range of options for motors, encoders and of course communication profiles like Profinet, EtherCAT, Modbus, TCP/IP and furthermore. Integrated safety technology with and without encoder are the key facts for this drive series. The next slide will show you some feedbacks and information from our customers, the machine manufacturers. We have got the challenge and advantages and opportunities in the machine sector. The current situation in the engineering part is the high resource effort in the developing of process of the new machines. The commissioning at all of components takes place on the real test systems in the technical area in the machine builder halls. And last but not least, the configuration of the PLC program and troubleshooting take place during the commissioning on site or in the engineering process. With this feedback from our customers, we develop an optimization potential through simulation models of the KEB drives. The benefits and the opportunities with the simulation models is the increase of efficiency. The simulation models support the engineering in the developing process of the machines. The virtual commissioning helps because the on-site commissioning becomes more efficient, and the virtual trainings for employees and customer trainings can take place virtually. And the reproducible test is another benefit for simulation models. The model depth can be adapted to customer requirements and the simulation environment. KEB is well known in different applications with different portfolio solutions. I will introduce you a short example of woodworking machines. A woodworking machine has got, let's say, many axes of CNC applications with EtherCAT, for example, field bus communication, for example, with EtherCAT, and the motor technology with high-speed motor spindles. The intensive commissioning and troubleshooting and tests on the customer application is one of the biggest challenge for our customers, and the expensive construction of the test system for these huge machines. With a very high model depth of our simulation models, we have got the benefit for you and your engineering process. How does it look like? We adapt our firmware code from our real KEB COMBIVERT F6 and COMBIVERT S6 drives to our simulation model. The representation of the real behavior is inside this simulation model. The scalability of detail of levels with different areas of applications can be solved with simulation models. The KEB designation of this type of simulation model means firmware simulation models because it's the real behavior of our firmware of our physical drive controller. The function overview of our simulation model is very big. Mostly all of our CIA402 operating modes are implemented in our simulation models. The connecting of the evaluating digital input and outputs is given. The selection of the KEB drive power size is also given in the engineering environment of your simulation environment. The import and loading function of our KEB parameter lists, work list is also given with these simulation models. Also, we have got access to the parameter directionary of the KEB drive controller. like the air parameter, run parameter, the protection parameter, and many, many more. Support of the real-time Ethernet communication over EtherCAT is given with the ISG real-time system. Last benefit for our customers is that we support the CAN Open protocols COE and Ethernet over EtherCAT. How does a real-time system in combination with our simulation model looks like? In this example, we have got on the left side the KEB workstation with our tool COMBIVERT 6. We have got a PLC with the EtherCAT communication and an environment with our simulation models, for example, the S6 or F6 simulation model. We have got a real-time target system. In this case, we have got the real-time target system from company ISG with the ISG Virtuos simulation tool environment. And we have got an ISG Virtuos personal computer where the tools are running. The output of the firmware simulation model to the system of our customers can be profiles like speed and position. The feedback is given as well and goes back to our simulation models. In this page I will give you an overview about the real-time system possibilities. On the left side we have got an HMI in our demonstrator, we have got a workstation, we have got a PLC with Ethernet and EtherCAT communication, and we have got two devices, one simulated drive and one physical drive. The simulated drive is running on the ISG real-time target system, and the physical drive is on the demonstrator is a given drive. Also, we can set up, let's say, some use cases and scenarios to get the engineering PLC error codes, wrong mapping behavior on the field bus programming of the EtherCAT communication, some error detections with wrong motor parameterization, and some specific error and fault reaction ramps during some drive-specific scenarios. With the help of this practical demonstration, I will show you some details how the simulation models can work and how deep is our simulation with the help of our firmware simulation model. This is a demonstration about the physical demonstrator. In this picture you will see the KEB Drive Controller F6, a PLC, the HMI of KEB, and the simulated asynchronous motor with a gear combination. On the left side we have got the 3D creator in the software ISG Virtuos. Also, the block diagram of our simulation model of our COMBIVERT F6 is given in the ISG Virtuos simulation environment. Let's have a look in some parameters. This COMBIVERT project has got the communication to the KEB drives over the communication protocol COE. At first you will find the simulated firmware simulation model of our KEB F6 drive and the real EtherCAT COE drive from our demonstrator. Both are running over the PLC of KEB and the communication is given by COE and EtherCAT. The simulation EtherCAT COE drive you will find here shows some values about the simulation model. For example, the speed, the set speed, the ramp output speed and the current situation of our drive. Also, the simulated DC bus voltage. The real EtherCAT slave, the physical drive of KEB, is given in this real EtherCAT slave. That means you will find, of course, a real current behavior, some all other parameters, and of course, a fluctuating DC bus voltage. This is a communication to the COE channel, to our firmware simulation model and the real physical drive. The first use case I like to show with our firmware simulation model and the software ISG Virtuos is a high over temperature of the motor. With the simulation model you can easily set up some wrong settings of the environment of our KEB drives and the motor and the PLC programming and some static and other error diagnostics. That means in this case the current motor temperature is around about 50 degrees because it's given from the digital input or the input of the motor temperature to our firmware simulation model. Now I will change the 50 degrees to a higher value to simulate a warning temperature in our firmware simulation model, so the KEB drive. I like to force the value. Now the value changed from the firmware simulation parameters to the 110 degrees, and we will get a warning drive overheat. The next step is that we increase the value in the ISJ Virtuos simulation environment on the motor temperature input over 150 degrees. I like to force the value. Let's have a look at the 3D demonstration. And I like to force the value. Now the simulation stops because we will get a drive overheat. That means a real behavior of a high temperature on the motor side in a simulated way. Second part. Now the simulation is running again, and I will show you another possibility of errors. Now I like to show you if the user enters some wrong parameters in a static way of the current motor which is connected in the simulation model. You will find here, for example, the device information in our DE parameter. What is the nominal current of our KEB drive which we are simulated? 17.5 amps. The motor current is around about 2.55 amps, and now I will change the rated current of the simulation model, so of the motor, to a higher value as allowed. That means now I have to fill out the motor data. I will go to the initialization process of the KEB motor data, and we get the information error drive data because it's a routine in the background which checks the 200 amps are too high for this KEB drive controller and the simulated firmware simulation model.